Hello, and welcome to this YouTube series I'm creating of videos on the automating of a test of a complete software stack that I created earlier in a project, not earlier in the year, but actually over several years, where we tried to automate as much as possible and have a test system that was not just unit or system level test, but we were even testing it on the whole operating system kind of level. In order to achieve this, we use several different tools like Yocto, GitLab, of course, some standard tools as well, like NFS booting and whatnot. So I'm going to start the series by talking about how to set up PXE booting, and then the next session will be on setting up a Yocto build system and deploying it via PXE, and then we'll automate that in GitLab, followed by creating an actual Docker image from Yocto, which has been done before I did it. I found a few hints online, but there wasn't really actually anywhere where there was an explanation at all. There was a paper somebody wrote one time or a presentation they did, but they didn't talk through the how-to. And I've written a paper subsequently as well on this whole kind of doing it on this level where you automate it. But I wanted to add out the how-to as well and prevent somebody else trying to do it and having no guidelines like I ended up having to do. We'll then add the testing of the image that was deployed via Docker into a Docker image into our GitLab runner, and we'll test also our image that we'll PXE boot. We've got an extra bit as well that I want to add in, which is creating additional methods for the booting process of Yocto. So I went with ramfs, as I called it, and HTTP. HTTP, I got the idea from how Ubuntu can load from HTTP. I noticed that one day when I was playing around with it in the early start, so I thought that was pretty cool. ramfs was kind of an extension of that. I didn't really like NFS booting because it requires a consistent connection. So ramfs is sort of a version of NFS booting, but it stores the whole OS image. So it downloads the whole OS image in the first place, rather than just what it needs as time goes by. So it gets it all, puts it into RAM, and has RAM as its root system, and doesn't really require the connection to NFS afterwards. So that's why I didn't like that NFS. It's a need for a constant connection via the network to the original source of the NFS image. But you can sync back up with the NFS image if you want to write to. You can use rsync. I think that's the best tool I would have used anyway. And that also similarly, it wasn't really super well documented. It was something I had to piece together from people mentioning you can sometimes when you're searching Doctor stuff, you'll see mail between other people that happened in old forums. So that's where I pieced that together from. So anyway, to get started, we'll start with PXE booting, and some principles I've laid out is for client, and some principles about PXE booting and how it works is that the client will boot up. It will announce what is my IP address, as any device does. A DHCP server will respond, and in that response, it also sometimes provides next server if there is an NFS system, and a file that it needs to grab, and that will be the bootloader. The next thing the client then does, of course, is then contact that next server and download that bootloader. And that bootloader gives it a menu selection for options. In our case, we're going to have default. So if you imagine this is somewhere where humans can't go, then even though there is a menu selection, it will default after a set timeout and boot up from there. The menu option will define what is the kernel, what is the init file system, and ultimately where to get the root from. And a note here is that an init file system is a minimal root file system used by the kernel in the startup process. It contains what is required to load the ultimate root and then switch to. So for example, if we were doing HTTP loading, we would have wget in that init file system. So it's not the kernel. It's a small root file system with just enough programs to do what it needs to do to get the rest of the file system. and it would have like root switch, for instance. For that final step, once it has the root file system, it needs to switch over the kernel from itself to the actual. A little description of my setup as well. So what I've got is I've got a Raspberry Pi 4. This is acting as my DHCP server, my NFS server, and my TFTP boot server. I've got a Intel PC laptop that I've selected for BIOS UEFI PXE booting, only on IPv4. I find, putting in IPv6 into the mix is not necessary. We've got a very small network, and it just gets confusing. The laptop only supports UEFI booting, but I will show BIOS Legacy as well. In the formation of it, I don't have a BIOS Legacy supporting machine to actually show that. I've got one switch and I've got two Ethernet cables connecting those if I ever switch. I've also got this indication of a Wi-Fi network. So the Raspberry Pi is on like my actual normal network, which is how I communicate with it through this laptop. But then it's got this kind of private network that it's going to host with the DHCP server, which is where the switch is and where the other laptop is. So at the end of the video, when I've actually got this working, I won't really be able to show the laptop actually booting up. So you're just going to have to trust me on that. To get started, I'm starting from a blank Raspberry Pi. I've literally just imaged it, and the reason for that is so that we're working from the same base principles. So as a result of that, I'm going to have to actually perform the update. Cool, now that's done. I can then install the first few packages I want to use. So I'm going to use isc-dhcp-server. I know that other people use other DHCP servers. This is the one I found kind of reliable, so I like to use it. We've also got to install, obviously, TFTP, which is going to be what hosts the bootloader and our root file system. But usually you'd actually use nfs-kernel for that ultimate bit. For today, we're not going to use nfs-kernel. We're going to actually HTTP boot Ubuntu. I'll show NFS booting in a later video when we have Yocto. So let's install those. Oh, syslinux. I think it's syslinux-common I might need to install. Yeah. Cool. And then, so now I've got the packages installed. Let's get the network working correctly. So I have got Ethernet 0 plugged in and the switch powered on. Not the laptop, that's enough to activate the Ethernet port. But I've also got this annoying name of wired connection 1, which is standard in the new format of Ubuntu, or which I think Raspberry Pi is running Ubuntu. I think that's what it natively gets installed with the imager now. So I'm just going to rename that to F0. And when I do show again, yep, it's now F0. And I want to disable the IPv6 method just because. Cool. And what that also does is it makes the NM connection file for me. So I want method to be manual on my IPv4. And my address, I'm going to set it to work in the range of 1. So 192.168.1. I'm going to give my Raspberry Pi the IP address of 0.2. And the broadcast address is 0.255. And my subnet mask is -24, as in all of it, in the final fourth range. So this should be it. that should do the job nicely of setting a static IP address on my IPv4 of that Fnet port. So I can restart the network manager there. And if I do ifconfig post that restart, just take a second. And of course, just going to double check or at least show that my actual network is 0.0. So these are two separate networks now. And you can see that 192.168.1. And then my Wi-Fi network is 0.0. Next, we're now going to start, now we've got the Ethernet connection set up, let's start by setting up our isc-dhcp server. And the first thing is obviously, we've just done the Ethernet connection, so let's point it to our Ethernet interface. And then we need to modify and give our DHCP server a bit more detail about what we're doing. So what we're going to do is we're going to say to it that we are authoritative, which means that it administrates the DHCP leases. We're going to have some optional space for PXE Linux, log facility. We're going to allow booting and allow bootp. These are sort of like, you don't need to put these in, I found, but it's okay to have them there, so I might as well have them there. It's this client system architecture code that is the important bit. So it is an unsigned integer that we receive back. And basically when the client starts up and it sends out that DHCP request, alongside that DHCP request, it sends a sort of definition of what it is on a basic level, little integer tag. And that's where we can go, okay, well, if it's 0, it's legacy BIOS. If it's 6, then it's 32-bit UEFI. If it's 7, it's 64-bit. And if it's hexadecimal OB, then it's going to be ARM 64-bit. And that way we can pass it the correct bootloader file. In this definition, we've said to our DHCP server as well on a network level that we've got this subnet of 192.168.1. The range is 0.2 to 254. Of course, we could have 0.1 here, but we don't. Our router is 0.2, which is our Raspberry Pi, so it's saying it is the router. Broadcast address matches our ifconfig from before. Subnet mask is fairly typical. And then, so then we match a PXE client and we tell it which file to go get. And then we also say our next server is ourselves, but that could actually be like what we do next with the TFTP. You could put that on another machine. I don't see the point. DHCP isn't actually that like consuming to processing power, so TFTP can run fine as well alongside this. So I'm going to save that now, and then the next bit I'm going to do is restart my DHCP server. Okay, so that should be the DHCP server now set up. The next bit is we're going to have a quick look at our settings for TFTP, and they're pretty standard. We might want to say that we want to have it latch to the 0.0.0.0, because when you say 127.0.0.1, it actually latches to one Ethernet adapter or one Wi-Fi adapter, it depends, whereas all zeros is every connection. 127.0.0.1 latches to the link local. So if I go back and I'll show you that, that's right here. So LO, not hello, but LO. For local, and you can see it's got the 127.0.0.1. So if you put that thinking I'm just telling it local, then it will just it won't broadcast anywhere. But zeros says broadcast everywhere. Cool, and we've got a username as well that'll become important later. And this is a directory, a pretty standard directory where we're going to do all that work. So the next bit is okay. So let's start by installing some of our stuff. So I said earlier that I'm going to have Ubuntu accessible via HTTP. So in order to do that, I need a HTTP server. So I'm going to use Apache 2. This is only temporary for lesson 1. We won't use it for any of the other videos. I want syslinux-common and PXE Linux. That'll give me the files I need for PXE Legacy Booting. But again, we're not really actually going to do that. We're going to do Grub booting and the newer UEFI booting. But even so, we'll set it up anyway. So if your machine is only legacy supported, I'm not limiting this, limiting you out as a target audience. Okay, cool. So what we're going to do now is just check our address for the server. So TFTP, cool. And then we're going to start by getting one of those first sets of files we need, which was PXE Linux. So we're going to copy that from our installed PXE Linux package. So now we have that in our TFTP location. All of these go off the wrong. All of these instructions I've got stored, so I'm just going to fix that as well. Oh, I should fix up here as well, common. It didn't quite work. And I've got a typo there as well. So I'll upload these as a description to the YouTube image as well. I always hate it when you have to then manually write out the instructions because I didn't put them down. So the next thing I'm doing is I'm making sure that that folder is actually owned and modifiable by TFTP, so that when it serves it up to clients, it can access it to give it to the clients. I also need some other auxiliary files. This is what syslinux-common was installed for. Cannot create regular, oh yeah, because that is not a directory. And then, so that should suffice for our legacy booting. You might find you need to install other legacy files. Similarly, they will be in the syslinux-common directory. But yeah, that should do. The next bit is the UEFI booting process. So that's mainly via Grub. So we're going to create a Grub folder. And we're going to then create our Grub menu. And we're going to set the timeout for 5 seconds and the default to 0. And I'm going to add in my installing Ubuntu process. I'm also going to add in my run Yocto for, in fact, we'll delete that. I know you're probably seeing Nano and thinking, oh God, I'm not going to listen to this person. They're not using Vim, but to each to their own, right? Okay, so I've got my Ubuntu set up and I'm telling it that my kernel is VM Linux, my init file system is init-rd, and that this URL, and this is what's important. So when the client's booted up and it's got the DHCP address, it's communicated with the DHCP server, and the TFTP, and it said it's been told where to get a bootloader from, and it goes and it grabs this file. Alongside sort of a binary on the actual bootloader, but the menu is the important part. The next part is the menu tells it, this is the kernel that you need to grab from TFTP. This is the init file system that you need from TFTP. And then it's the kernel as it's loading up. It then takes all of these additional parameters. So this boot equals Casper. I don't actually know what that means. That seems to be specific to Ubuntu. Your URL, and your IP equals DHCP. So IP equals DHCP is a fairly standard Linux kernel command, and it basically says keep to the, well, in this case, it helps keep to the IP address it gets at the boot process. So if you imagine that like that IP address actually cuts off halfway through this because the kernel's loading, that won't work. That'll be quite disastrous. So you want to keep that the same, and this is what that parameter does. The URL part tells the kernel that okay, now you're going to boot up from and get the rest of your root file system from this ISO. So that's what it does. It goes into that mode of loading from HTTP. And of course, we've got our timeout set to 5 milliseconds at the top. 5 seconds, not milliseconds, sorry. That'd be impossible for a human to interrupt. And default equals 0. So great, that's our Grub menu set up. The unfortunate bit is that Raspberry Pi doesn't support the Grub menu setup, so I can't just install it here. So I have to install it on my alternative machine, which I'll do now. So I've got a PC. This PC actually will come up in video tutorial 2. This is where I actually host my Yocto build system. So if I do that, you'll see Yocto Mate. Cool. So the next bit is I actually want my Grub files. So I'm going to make the grub, cd grub, and then copy the relevant file I want. I'm only going to show this file for now. I found it a bit tricky to find the other files, but I'm sure you can. But yeah, I'm not going to waste time on that. Okay, so because the Raspberry Pi has been reimaged, it doesn't recognize it. So let's try it now. There we go. Cool. And then I'm going to put my signed image into the TFTP boot sector. What? Oh. There we go. Okay, now back to our Raspberry Pi. So we've got the Grub menu. We've got the Grub bootloader now. That was sort of what the binary was that we just transferred over. We now need our legacy boot process. So we're going to create that. Our file exists for that. Apologies about that. I got a bit confused about what needs to happen there, but ChatGPT to rescue, despite my poor spelling on my question, is what is the directory structure at TFTP for legacy booting, and that is that we have the .0, which is our bootloader file. We have some required files, which is this one that I've given us already. And then we have a directory which has the PXE Linux configurations. And the default is what we're going to mess with today, but you can have Mac specific ones, you can IP address specific ones. The boot sector as well, that is actually defined by the config. So it doesn't necessarily have to be boot / blah, blah, blah. Let's make that directory. And then let's set up our menu. Okay, very similar to before, all the same kind of stuff. So I'm not going to go through it too much. Going to then make, I might want to set up indenting. So it's all the same. Going to make, our Ubuntu location. And now we're going to switch over to where our Apache server is. And we're going to get our release document, ISO. Okay, so now that that's downloaded, I'm going to mount my ISO, sorry. Cool. And the reason I'm going to do that is I need several files from it. So if we just show you that. So I need my VM Linux Linux kernel, and I need my init.rd, which it has. So great. So we'll copy all that and we'll put it in our Ubuntu folder that we created. We'll do the same for the kernel. The init file system takes a little bit longer to boot up because it is multiple files, really. It's actually a CPIO GZ zip folder. Cool. And then we'll make the var www.html accessible. That should be it, actually. So I've set up now. So if I go back to TFTP, we just have a look. I've got my UEFI, sorry, I've got my legacy booting, but I've also got my UEFI boot, grub boot. And my grub boot says go to Ubuntu folder. Both do, actually. Go to the Ubuntu folder, get the init file system, get the Ubuntu kernel, and then load from Apache the ISO. And Ubuntu handles it from there and knows how to do that. So the next thing, now I'm booting up my Dell laptop. Sorry, I didn't say it was Dell before, but it's getting the IP address. Let's see if that works. Okay. Proceeding, it's got a menu now, a grub menu in fact, which says install Ubuntu. I'm just going to leave it. It timed out. And next bit is actually grabbing that Raspberry Pi from the Raspberry Pi files. And now it's loading. Brilliant. That all worked. Great. Well, that's the first stage. A fairly well documented process, admittedly, but it's the first stage to show in the series for setting up a whole kind of continuous integration pipeline where we're testing on multiple levels, not just our application, but our operating system. We're building our operating system from scratch, but we're automating that whole build system. And the reason I want to do that is because I need to have a real-time kernel. And I found just, doing all of these tasks were tedious. Automating it together, that was a really great part that made it so we could focus on building our application, not everything that has to go around it. Cool. Well, look forward to, hopefully enjoy it, but and see you in the next video.